How are you guys? Welcome back to my YouTube channel. Today we'll be dealing with strength of material N6. We'll be looking at longitudinal stress in a single cylinder, single cylinder, right? But obviously, we are dealing with thick cylinders. Remember, N6 we only focus on thick cylinders. Only focus on thick. Forget about thin. Even do not forget completely, but you want to see there's no thin here. Thin, we are no longer using, we are no longer doing thin, we're doing thick. Okay, it's fine. So I've given a definition of a thick cylinder. A pressure vessels with a diameter to wall thickness ratio less than that are called thick cylinders. If you can see, these cylinders, is what and what. So we are not there. Remember, just for recap, you can check a thin cylinder is a thin cylinder theory. The radial stress is ignored, but the wall thickness exceed one into 20 of the diameter. The radial stress cannot be ignored. For recap button, I want us to focus here. Longitudinal stress. We have longitudinal stress in thick cylinders. Yeah, during this is a single cylinder given. Longitudinal stress affect closed cylinders only. It says affect closed, take a note, affect closed cylinders only, not open. And acts on the end plate of the cylinder is shown. Acts on the end cylinder plate is shown. Here is given by stress. It's still the stress, but it is longitudinal stress, but we call it longitudinal stress. Longitudinal stress is pulling out that mental them. So what is given? Longitudinal stress is equal to longitudinal force due to pressure cross-sectional area of the cylinder wall. Here they've substituted for us. Then pi over 4 and pi over 4 will cancel. Then our final formula is that one. As you can see, P is pressure multiplied by D over D minus D inside diameter, outside diameter. As you can see here, we have given this longitudinal stress is measured in Pascal. P is longitudinal pressure, diameter is the internal diameter in meter, external diameter of the cylinder also in meter. So yeah, let's check out, can we use this formula? If example 1 says a high pressure cylinder with the internal pressure, which is D, which have a D there, which is 250, same as 2 when you divide by 1000, and outside diameter will be 0.35 meter, and must withstand internal pressure of, okay, we've given our pressure of 15 megapascal. Says calculate, to tell us to calculate the longitudinal stress in the cylinder wall. Obviously it's acting in the wall. So okay, it's fine. Our solution, I've said longitudinal stress is equal to pressure, internal pressure multiplied by internal diameter squared over external diameter squared minus internal diameter squared. So yeah, so we can longitudinal stress would be equal to pressure We are given there's 15 megapascal. 15 times 10 to the power of 6 times the diameter internal, I said 0.25, you square that is 0.25. Then outside diameter is 0.35. This will be over 0.35. You square this 0.35 squared minus 0.25 you square. This is how you find the longitudinal stress. As you punch that, supposed to get that longitudinal stress to be equals to 15,625 megapascal. So this is what it is in this video. Thank you guys for watching. Please subscribe to my YouTube channel if you have not subscribed, and click that notification button so that you'll be notified whenever I post a new video. Share this to your fellow classmates. You can comment, you can like, you can share, feel free. Thank you for watching.